All right, folks, let's take a look at our first example problem. We're going to be writing equations today, and this happens to be a graph, so we're going to be, in this problem, writing an equation from a graph. We're going to do a table in just a moment. So there's a couple of items that we have to do here. You're going to have 4 of these problems in today's class. You're going to have about 30 minutes to complete all 4 problems. So the first thing we want to do when we're writing an equation for a line is to follow these 4 steps. So the first thing we want to do is we want to identify the y-intercept, and we want to find the coordinates of the y-intercept. So in this problem, the y-intercept is right here. Those coordinates are 0, 3. Label the y-intercept on the graph, which is what I've just done. Then we're going to identify at least 2 points that are on the grid and on the function. So here we have a point. It touches right here and right here again. And here, all we need are 2 though, but I've identified all of them. Because what we're going to do next is using these points, we're going to draw the rise and the run, which is the slope triangle. So we're going to connect the points, and let me connect this one because it's up at the top. So we rise to go from this point to this point. We rise 2, we run 1. Let me do that again. So to move from point to point, what do we need to do to move from point to point? We rise 2, we run 1. So that was step number 3. Step number 4 is label the units of the slope triangle, including direction. So what do I mean by direction? First off, if we're going up this way, this is the positive side. This is going up. If we are moving down, that would be negative. When we're moving to the right, this is the positive direction. When we're moving to the left, that's the negative direction. So if I start here and I go up is positive, so positive 2 units. And if I move to the right, that's a run of positive 1 unit. So I've labeled my y-intercept, which is right here. I've drawn my slope triangle, and I've labeled it. This is exactly what I want to see on each one of your graphs. Now let's continue working through this. We're going to write the equation for the function. So we know that we need to use slope-intercept form. So y equals m, the slope, times x plus b. And here, in fact, I did this incorrectly. This is not 0, 3. 0, 3 is up here. This is, in fact, 0, negative 3. So our slope, our m, is rise over run, which is 2 over 1, which equals 2. So my equation is y equals 2x. And because that's a negative, that's going to be minus 3. So the equation for this graph is y equals 2x minus 3. Label the y-intercept on the graph. Y-intercept is right here, right in between 1 and 2. So that's going to be 1.5, 0. And you're going to work your way down the line. What are the coordinates of the 0? It's exactly the same as the y-intercept, 1.5, 0. I need to label that x-intercept. Is this a function? Yes or no? It passes the vertical line test, so yes it is, because vertical line test. Is the graph continuous or discrete? I see a line, so therefore it's continuous, because I see a line. Now, these graphs go off to the edge just like your calculator does. So if the graph runs off of the edge of the page, that means that the graph has arrows on it. It does not stop. So my domain, negative infinity, less than x, less than goes positive infinity. And if it continues to go negative, that's negative infinity, less than y, which is less than, continues to go up forever, positive infinity. Now then you're going to have to follow the last couple of 10 and 11. I'll let you figure out for yourself. You need to figure out the input and the output value. Depending on, if I give you the output is 8, what is the input? If I give you an input of negative 4, what is the output? Hint, you might have to solve a problem. You might have to solve the equation given these values. And lastly, explain how this function compares to the parent function. The parent function, you remember from your last video, runs through the origin. Whatever I put in is what I get out. So this, our current equation, is translated 3 units down. And if this is the parent function, is this steeper or less steep than the parent function? Is it steeper or less steep? This happens to be steeper. It's the angle's increasing. It's increasing, so therefore it is steeper. And believe it or not, folks, that's all you need to write for this. You tell me how far does it go up and down, how many units, and then tell me is it steeper or less steep. That's everything you need to do for this problem. The next video will show you how to construct the table.